Hi everyone, hope you are doing great today. Today I'm going to start chapter 2, which is organizing data. Under chapter 2, section 2.1, we are talking about variables and data. So there are few definitions. First, we need to check what are these variables. What is the variable means? Variable is a characteristic that varies from one person or thing to another. Variable is some kind of you can think like this. Variable is like a storage device. You can store your information in that particular variable, like same as they have mentioned here, from one person, that varies from one person to another. Yes, it is different from one to another. The next one is qualitative variable. Qualitative variable mean it is a non-numerical valued variable. For an example, eye color can be black, blue or green. There is no numerical values in there. So qualitative variable is a non-numerical value variable. Quantitative variable, which is a numerically value variable. So qualitative and quantitative, very similar but two different ideas. Qualitative variable has a non-numerically valued variable. Quantitative variable is a numerically valued variable. It has a numerical values. For an example, weights of students in the class, numerical values. Next one is discrete variable. Discrete variable means a variable which has discrete values. Discrete values mean counting values like 0 to 1000, 0 to infinity, or negative values, but uh, integers, definitely integers. Discrete mean integer values. In particular, quantitative variables with only a finite number of possible values is a discrete variable. Continuous variable, which means a quantitative variable whose possible values from some interval of number. If you consider an interval, let's say from 10 to 1000, that's my interval. So between that 10 and 1000 you can pick many values. There are infinitely many values: 10.5, 12, 100, 105, something like that. Okay. I have just categorized them like this type of variables. Variable, we have two types of variables, qualitative and quantitative. For the qualitative, eye color or gender. Quantitative, weight, height, number of siblings. So uh, quantitative, you can again divide into two pieces, discrete and continuous. If you consider these three examples, so under quantitative, discrete quantitative variable is a number of siblings. It has a discrete number like 2, 3, 1, 0, something like that. There is no 1.5 siblings. There is no 2.3 number of siblings. So it is discrete. Continuous, weight, heights are continuous. So height of that particular student is uh, 1.5 meters, something like that. Okay. Okay. The next definition is data. What is a data? Data is a values of variables. Simply a collection of variables. Data mean collection of variables. Again, we have those four guys here: qualitative, quantitative, discrete, continuous. So qualitative data, you know what is data? Values of variables. So qualitative data mean values of a qualitative variable. Quantitative data mean values of a quantitative variable. Under quantitative data, we have discrete data and continuous data. Discrete data mean values of a discrete variable. Continuous data mean values of a continuous variable. So as you can see here, data divided into two pieces: qualitative data, which mean values of qualitative variable; quantitative data, which means value of quantitative variable. Under this quantitative data, we can divide that into two pieces again: discrete data and continuous data. Discrete data mean value of discrete variable. Continuous data mean value of continuous variable. uh, each individual piece, each individual box, we call uh, observation. We call this is an observation. This is an observation, something like that. Okay. Each piece of data, if you have data like qualitative data, each piece of data we call an observation. Okay, so collection of observations for a particular variable we call a data set. Okay, collection of data we call a data set. Here I have mentioned example of qualitative, discrete, continuous. Qualitative variable, let's say blood type, it includes AB, uh, ABO, something like that. Okay, data, this is the data, this is the variable is the blood type. Data ABBO, AB plus, something like that. There can be repetitions. Okay, data, there can be repetitions, no problem with that. Marital state, marital states, that can be married, unmarried, single, something like that. Married, single, divorced, something like that. Under qualitative, variable, marital state. Then if you consider discrete case variable, let's say number of siblings, you have data like 0, 1, 2, 3, 4, something like that. As I mentioned here, 1, 3, 0, 0, something like that. And number of pets, variable is number of pets, again it should be a discrete value, 0, 1, 2, 3, 4, whatever, so on. Okay. When we consider continuous, if continuous variable, let's say weight of a newborn, data can be 6.7, 7.1, 8.72, something like that. Okay. Section 2.2, we are talking about how we organize this qualitative data, non-numerical data. Okay. First thing is we are trying to uh, draw them under frequency distribution. So we call this frequency distribution of qualitative data. So we are trying to show them under numerical calculation or numerical method. A frequency distribution of qualitative data is a list of the distinct value and their frequencies. How many times that distinct value appears, something like that. So I have mentioned the specific steps how to draw this frequency distribution of qualitative data. First, you have to identify what are the distinct values. What are the distinct values in your problem? Then, uh, then each observation place a tally marks. Tally marks. You are going to count how many observations I have under this distinct value, something like that. Last step is count those tallies for each distinct values. Simply you can skip the second step and perform the third step. So easily there are two steps. First list the distinct values, then count the frequency or count the number of occurrence belongs to that particular distinct values. It's like this. There is a political party affiliations of the students in industry statistics. You can see Democratic, Republican, and other. So in this case, throughout these 3, 6, 7, 8, 40, throughout these 40 observations, you have only 3 distinct variables or 3 distinct values: Democratic, Republican, and other. Do we have any other? No, right? Just Democratic, Republican, and other. These are the distinct values in this problem. Okay, so you have 3 distinct values. So now you have to count how many Democratic are in this picture. You have to count Democratic: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there are 13 Democratic. Likewise, you have to calculate, you have to count how many Republican, how many others in this picture. So I have mentioned here Democratic there are 13, yes, Republican 18, others there are 9. So this is how we do our counting. You don't need this tally part. If you want, you can just use this one. So at the end you can add these frequencies and take the final count. There are altogether 40 observations. So yes, when you add these frequencies together, you can see it's 40. Okay, so this is the frequency distribution of qualitative data. Okay, this is same as the previous example. I have mentioned here students. Suppose we select 15 students from this math course. Find out the most preferred food. So P mean pizza, B mean burger, S mean salad. So this is my data set. I have 3 distinct food: pizza, burger, and salad. So I have mentioned them here. I have to count how many pizzas are there, how many burgers are there, how many salads are there. I can help you that I can count. There are 1, 2, 3, 3 salads. Okay, 3 salads. Then you have to you have to count how many pizza, how many burger are there. Altogether, you can see that 6 and 9, 12. There are 15. Yes, there are 15 preferences here. Okay. Uh, Next one is we are trying to identify this frequency distribution with relative to something. Okay, we are going to uh, identify this frequency with a relationship to someone. So a relative frequency distribution of qualitative data is a listing of the distinct values and their relative frequencies. How we generate these relative frequencies? We do like each frequency divide by total number of observations. That's it. Okay, I'll show you. First, obtain your frequency distribution like what we have discussed so far. Then divide each frequency by the total number of observations. Okay, in this one, you have seen this guy a few pages before. This is your frequency distribution. See, Democratic 13, Republican 18, others 9. Altogether you have 40. Okay, altogether you have 40 observations. Now, when you convert that into a relative frequency, what you have to do is divide each frequency by total number of observations. Here total number of observation is 40. So divide each instance, each frequency by 40. 13 divided by 40. See, it is 0.325. 18 divided by 40. It is 0.45. 9 divided by 40, 0.225. Okay. Then when you add these relative frequencies, sum is 1. Sum is 1. So always when you add relative frequencies, sum is 1. Sum is equal to 1. Okay. Okay, consider this example. I think pizza, burger, salad. Yeah, the same example we have discussed before. There are 8 pizza, 4 burgers, and 3 salads. Altogether, we have 15 uh, foods or 15 preferences. So relative frequency goes to how much for pizza? 8, which means that frequency divided by total number of foods or total number of preferences. So 8 divided by let me write it, 8 divided by 14. 8 divided by 14. Next one is for burger. 4 is the frequency divided by 14. Salad is 3 divided by sorry, this is not 40. This should be, where is my eraser? Give me a second. I'm so sorry. This should be okay. I confused with the last example. I'm so sorry. Here for pizza frequency is 8 divided by total number of preferences, there are 15. For burgers there are 4 divided by total number 15. For salad it is just 3 divided by 15. Okay, so percentage you can directly take like this value 8 over 15. You can calculate by using calculator, no need to do it by hand, just calculate it. This value, this relative frequency, when you multiply this relative frequency by 100, okay, I'll show you that. This guy multiply by 100, you can have your percentage. If you multiply this by 100, you can have your percentage. So always relative frequency multiply by 100, you can have your percentage value. Okay. Next one is pie chart. We can show this, we can show this um, qualitative data by using a pie chart as well. Pie chart is a disk divided into wedge shaped pieces proportional to the relative frequencies of the qualitative data. Again, you have to obtain a relative frequencies, relative frequency distribution of the data by applying our procedure we have discussed before. Divide disk into wedge shaped pieces proportional to the relative frequency, so that disk size proportional to the relative frequency. Label each slice. That's very important. You have to name them. You have to label those uh, pieces in pie chart. Okay, in this pie chart you can see same example, Republican, Democratic, other example. uh, According to the frequency we have drawn this pie chart. I think for the Republican it is 13, Democratic I don't remember the values, but uh, according to that value you have to calculate this percentage and draw this pie chart. Okay, that number of that frequency for belongs to Republican, divide by total number, multiply by 100%, you can take this value, you can get this value. Same here and same here. Okay, there's a problem. What is the wrong with this pie chart? It is perfectly drawn, like they have named them, each piece they have name, it has a title. Okay, everything is clear, but what is the problem here? Okay, give me a second, check this one. They have name, it has a name, each piece has a name, and they have each piece has their own percentage value, right? So when you add these percentage values or take the summation of these percentage values, it equals to 100%. Okay, so in a pie chart, percentage values should be summation of percentage values should be equal to 1. Can you see it here? 70, 60, 60, 70 plus 60, it is 130. 130, only these two, plus 63, it is 193. 193 percentage inside this. Is it possible? No, it is wrong. That's the problem here. Definitely this summation of these percentage values equal to 100. Okay, so I think you have now you have a better idea about these graphs or charts, how we explain or how we draw conclusion about this uh, qualitative data, non-numerical data. So in next video I'll explain you how we deal with quantitative data. So hope you have identify up to this point what are the charts and what are the frequency distributions, how we deal with qualitative data. There is another chart we call bar chart we use to display this qualitative data. A bar chart displays the distinct values of the qualitative data on the horizontal axis and the relative frequencies on y-axis or vertical axis. Okay, the bars should be positioned so that they do not touch each other. Remember that in bar chart, bars do not touch each other. Height of the bars represent the frequency or relative frequency of that particular distinct value. So how we draw this one? How we construct a bar chart. First obtain relative frequency distribution, then draw a horizontal axis and place what are the distinct values on x-axis or vertical or horizontal axis. Then vertical axis we mention the frequencies and label the bars with distinct values and horizontal axis with the name of the variable, relative frequencies or frequencies. Then draw the bars. Height, remember that heights of the bar represents this frequency. Okay, this is an example based on a previous example, the Democratic, Republican and other example. X-axis, this axis mention party, Democratic, Republican, other, those are the distinct values. So in y-axis or vertical axis, here represent relative frequency. You can draw this for frequency as well. If you use frequency, that height of the bars can be very large. Okay, if you need to shrink that size of the bar, you can use relative frequency. So all values in between 0 and 1. if you use relative frequency for the vertical axis. See, democratic, it has 0.35, something like that, height, which means democratic has 0.35 relative frequency. Republican has 0.46 roughly percent, roughly 0.45 relative frequency. When you multiply these values by 100, you can get the percentage. Okay. Okay. I think this is the end of this chapter, end of this section under qualitative data, how we represent qualitative data. We discussed relative frequency distribution first, then relative frequency distribution, bar chart, and pie chart. So these are the prominent ways how we denote this or how we represent this qualitative data. In next section or next video, I'm going to talk about quantitative data, how we deal with quantitative data, how we represent them, something like that. So I hope that you will enjoy you enjoyed this video, and we will see what is going on with quantitative data in next video. So thank you and